My name is Ba. I'm the Science and Math tutor at the NAS. Today I'm coming to make a video on college algebra. The topic I will be doing is 5.3. Yeah, 5.3. That is the graph of rational functions. So the subtopic I'm going to do is how to analyze a graph of rational functions. So I will use the college algebra book and take like an example in there and just do that one. So that's what I'm coming to do. Okay, the question I'm doing is going to be from the college algebra book. It will be an example from the college algebra book. So the question is, I'm gonna go ahead and write the question. Okay, it's this question here. R of x. R of x is equals to x minus 1 over x squared minus 4. So the question is this one. What I'm doing is how to analyze the graph of a rational function. So this is the rational function here. R of x is equals to x minus 1 over x squared minus 4. This is 2. This is 2x squared minus 4. So this one, it involves like a lot of steps. You have to go like step 1, step 2, step 3, step 4. It's like a lot of steps. So I'm going to go step by step and analyze how the graph of this function is going to look like. So the first step I'm going to do is to find the domain, of this rational function. That is going to be my first step. So I will list that as step 1. So step 1 is to find the domain of this function. So the domain of this function is like all the values that will be able to go in here. That is the domain of this function. All the values that will be able to go into this x, all the x values that will be able to make this thing defined. So this thing is only defined when this part is not equal to 0, because we cannot divide any number by a 0. So it's only defined when this part here, this is called the denominator, the upper part is called the numerator. So it's only defined when the numerator is not equals to 0. So whenever the numerator is equals to 0, this function is not defined. So the domain is all the numbers except any number that is going to make this part here 0. So to find that, this is step 1. So let's go and factorize this one and see what numbers would make it 0. So it will be R of x is equals to x minus 1 all over. If we factorize this, what we're going to get is, this is the same as x squared minus 2 squared, because 2 squared is like 4. So it's the same as x minus 1 all over x plus 2 into x minus 2 is difference of 2 squares. Whenever you subtract 2 squares, you write it this way. If this thing is like even another number, if it was 5, it's going to be x plus 5 into x minus 5. This called difference of 2 squares. Subtracting 2 squares, you just write it this way: x plus 2, x. Put the number that is on this side, put it here, and put it here. Put a minus on one of them and a plus of the other one. It always works like that. Okay, that is going to be step 1, is to find the domain. So which numbers will I put here to make this thing 0? If I put 2 here, it's going to be 2 minus 2, which is 0. 0 times that is 0. It means it's going to make all this stuff 0. So x cannot be equals to 2. If I put minus 2 here, it's going to be minus 2 plus 2, which is 0. And 0 times that is 0. It's going to be this thing over 0. Let me put the R of x here. So it means x cannot be equals to plus 2. So step 1, the domain of this function is all the real numbers. Like any other number you put there, it will not make it 0. The only two numbers that will make it 0 is x is equals to 2 and x is equals to minus 2. This thing is minus 2. X is equals to minus 2. So the domain is x is not equals to minus 2 and x is not equals to 2. That's the domain of this function. Every other number will be able to go into the function. So the domain is every number except these two, 2 and minus 2. That is the domain of the function. So that is the first step. I'm going to go ahead and do, I'll just put step 2 here. That one is step 1. Put step 2. Okay, step 2 is to write R in its lowest form. So here, like you see when we did that one, we don't get anything that divide here. This is the numerator part, this is the denominator part. So nothing divide anything up here, like everything is like in its form. So R is in its lowest form. R is in the lowest form. So this is the lowest form of R. So we should always like write this R in its lowest form. That is step 2. Like there's no common factor when we did this one. This one and this one, they're not the same. This one and this one, it's not like the same. So we don't get any common factor when we did it. We don't get any common factor. Now we don't get anything that we can factorize out. For example, if I say like 4x plus 2 is like going to be 2 into, it's going to be 2 into 2x plus 1. The common factor here is 2, but we don't get that kind of stuff here. So R is in lowest form. That is step 2. So we go ahead and do step 3. So step 3 is to find the intercepts of the graph. To find the intercepts of the graph. So here we just assume that this thing is like the y part of the graph and we get the x in there. So we'll just assume that is the y part. So to find the y-intercept is when x is equal to 0. That's going to be the y-intercept. So the y-intercept of this graph is going to be when x is equal to 0. So y is going to be equal to 0 minus 1 all over 0 square minus 4, which is equal to minus 1 over minus 4, which is 1 over 4. So the y-intercept of this graph is 1 over 4. The y-intercept is when x is equal to 0, y is 1 over 4. That is the x, this is the y. So that is the y-intercept of the graph. Okay, we find the y-intercept. Now we're going to go ahead and find the x-intercept. The x-intercept is when y is equals to 0. That's going to be the x-intercept when the y part is equal to 0. So that will be like 0 is equals to x minus 1 all over x squared minus 2 square, which is same as x squared minus 4. So if this thing, it means the denominator here is, what we're going to do here is to put this over 1 and we multiply that 2. So if we multiply that, it's going to be 0. 0 is equals to x minus 1. So x is going to be equals to 1. So 1 is the x-intercept of the graph. That's when y part is equal to 0, x is equals to 1. That is the x-intercept of the graph. So it's going to be at this point 1 and 0. It means this graph, whenever we draw it, it's going to cross the line this one is going to cross the x-axis at x is equals to 1. Like if this is the graph, x is going to be 1 here, like positive 1. So the graph is going to cross here where x is equals to 1, the x-intercept. So it's going to cross right here at x is equals to 1. That's going to be this point here, and the y-intercept supposed to be x is equal to 0 is this line. So that will be like around this end. That will be around this end. That will be the place is going to cross the y-axis and it's going to cross the x-axis here. That is the two intercepts. So that is our step 3. Step 3 we try to figure out the intercepts. Now let's go and do step 4. The step 1, step 1, step 2, step 3. Now step 4. So step 4, what we're going to do is find the vertical asymptotes. We're going to find the vertical asymptotes. So these are the lines that the graph will be approaching, but it will like never get there. So those ones will be the vertical asymptotes. Like the graph cannot be touch that line, and it will be like most of it will be approaching that line, but it will never touch that line. That is going to be the vertical asymptote. It's like the line we were going to get here, and the graph will come this way, getting closer to it, but it will never touch it, and maybe we can get another one, the graph this way. It doesn't matter. Like, so these are the vertical asymptotes. That's what we're going to get. So at this point, the graph will never reach there. So to find the vertical asymptotes, you look at the numbers that will make the denominator 0. That will make like the denominator 0. You know, whenever the denominator, this one is a denominator, this one is a numerator. Whenever the denominator is 0, this function is going to be undefined. So that will be a point on the graph that we cannot get any value for r, because the denominator is 0 means it doesn't exist. The value of r doesn't exist at that point. So what we're going to do is figure out the numbers that will make the denominator 0. That is the same as the numbers that are not part of the domain here. The two numbers we find, which is 2 and minus 2. So 2 and minus 2 are the only x values that will make this thing defined. Sorry, this thing undefined. So those are the two numbers that will be the vertical asymptote. So for example, if the graph is here, I would say 2 is on this side and minus 2 is on this side. So the vertical asymptotes will be lines here. That will be the vertical asymptote. So step 4 is the vertical asymptotes, which is minus 2 and 2. So we already get the vertical asymptotes here. That is our step 4. I don't know if the graph is. Okay, I'm gonna go ahead and fix it. That's like minus 2 here. I get minus 2 here and get 2 here. So these two lines are going to be the vertical asymptotes of the graph. It means the graph can get closer to these lines, but it will never touch these lines. It will never be on these lines, because at these lines there is no value for r. So it means the graph will never be on these two lines. But you can get closer to them, closer, but it will never get to them. Okay, I'll go ahead and fix that. Okay, that is the step 4. Now I'm going to go ahead and do step 5. I'll try. Maybe I'll try and turn the paper so that okay, I'll still put the paper up here. Okay, the next one is going to be step 5. Step 4 was to find the vertical asymptotes. Now step 5 is going to be to find the horizontal asymptotes. So the horizontal asymptotes of this graph, like this graph is x minus 1 all over x squared minus 4. The power of the numerator is 1. The highest power of the denominator is 2. So if this one, the highest power of the numerator is bigger than the highest power of the denominator is bigger than the highest power of the numerator, it means the horizontal asymptote here is going to be at 0, because this power here is bigger than that. So the horizontal asymptote here is going to be at 0. At 0 means like the line where y is equal to 0, which is the same as the x-axis, this line here. So we're going to check if the graph crosses the horizontal asymptote. So how to check that is going to be that x minus 1 over x squared minus 4 is equals to 0, because that is the line y is equals to 0 up here where it crosses this one up. So we did that earlier when finding this one, when we were finding the x-intercept, which was x is equals to 1. So at x is equals to 1, this point here, the graph crosses the asymptote at x is equals to 1. So that's where it intersects here at x is equals to 1. So it means we get this is the asymptote, but we still get this graph cross here at x is equals to 1. So that is the step 5 to find the horizontal asymptote. So the other one is going to be step 6. Step 6 is to take the zeros of this function. The zeros of this function is like the zeros of the denominator and the numerator. The zeros of the denominator and the numerator means the stuff that will make this thing equal to 0 and the stuff that will make this thing equal to 0. So those are the ones we're going to use, and we look at the intervals between them. We look at the intervals between the numerator, between this one, the zeros of the numerator and the denominator. So what we get here is when we calculate the other one, we get -2. The zeros of the denominator are -2 and +2. The zeros of the numerator are just 1. So we look at the intervals here. So when we start, like when you start, like remember it's going to be from -infinity to positive infinity, but we get these numbers between them. So we're going to find the intervals. So the intervals here, if we start all the way at the back, is going to be -infinity to -2. After that, we get -2 to 1, because after -2 you go to 1, after you go to +2. So it's going to be -infinity to -2. The next one is going to be -2 to 1. Next one is going to be 1 to 2, and the next one is going to be 2 to infinity. That is the intervals, going to be the intervals of the graph, because at this point here we get the vertical asymptote at this point here, and there's like a vertical asymptote at this 2 here. So these are going to be the intervals of the graph. Now what we're going to do, that is we're still going to be on step 6. So we're going to construct a table to like analyze the intervals and stuff, and what's going to happen, whether the graph is going to be below the x-axis or above the x-axis, like the value of r, the location of the graph, like the points on the graph and stuff. So that's what we're going to do. We're going to construct a table. So the table we're going to construct out, it will be, what we're going to find is, we already find the interval here. This is the interval. So I'm going to construct a table here. I'll put interval. We already found that one. So I'll find interval. We're going to choose a number. We're going to put that. So we're going to choose a number, and like within the interval we get here, maybe choose a number and see the value of r, whether the number is going to be the location of the graph, whether the number is going to be below the x-axis or above the x-axis. It's going to be location on the graph, location of graph, location of graph, and the third one is going to be point on graph. Okay, the intervals we get, I'm going to go ahead and write the interval. It was minus infinity to -2, that's an interval. The other one is -2 to 1, and the other one is 1 to 2, and the other one is 2 to infinity. So those are the intervals we get. So here we're going to choose any number. So I'm taking like the example from the book, so I'll take like those numbers from the book. So the number here is -3. They choose -3 because you can choose any other number. If you want, you can choose -5 as far as it's within this interval. As far as it is within -infinity to -2, you can choose any number, but I'll choose -2. That's what you can choose. I'll choose -3. Okay, -3, if you put it in r, that is r here. R is the equation x minus 1 over x squared minus 4. That is r. So if you put -3 into r, the result you're going to get, that is the location of the graph, r into -3 is going to be equals to -0.8. That's like 0.8. So 0.8, so we're going to, okay, I should put another section here where I say value of, probably put this thing on. I should get here value of r, but I don't put that row here. I should get another row here that said value of R, because we're going to find the value of R, location of graph, and point on graph, but I didn't write that one. So I'm just gonna go ahead and probably this one is. I'm just gonna go ahead and. So that is the interval. I already get that one on top. So I'm gonna rearrange those ones. After the interval, the next one is choose any number. So that one is like choose any number. After that, the next one is value of R. That's why I didn't get here. So I'm gonna get that one here. Value of R, location of graph, location of graph, point on graph. Okay, now I get everything. Choose any number. So the number we choose here was -3, and the value of R is going to be R of -3, which is equals to -0.8. So the location of that on the graph, is it going to be below the x-axis or above the x-axis? So that's -0.8. It's going to be below the x-axis. So I'll say below, I'll just say B. Yeah, below x-axis, I'll just say below x-axis. So point on graph. The point on graph is the x1 is going to be -3, and the corresponding value y value is going to be -0.8. So that's like below the x-axis. Why is negative? That's always below the x-axis. So that's why it's below the x-axis. So here we go to the second interval. We choose any number. That one, the number is -1. So -1, if R of -1, if you put -1 into R, the result is -1. If you put it into R, is 3 over 2 over, sorry, it's 3 over 2. 3 over 2. No, it's not 3 over 2, it's 2 over 3. I'm writing the wrong stuff. It's 2 over, it's going to be 2 over 3. So 2 over 3 is that above or below? 2 over 3 is above the x-axis, because if it is positive, it's above, negative below. So that one is above the x-axis. So the points we're going to get is -1 and 2 over 3. Always the number you put in and the number you get here is the point. So what is important here? The point on the graph, because that's what we're going to use to plot the graph. So the next one is 1 to 2. Between 1 to 2, the number they choose is 3 over 2. So 3 over 2 R, if you put it into R, 3 over 2 is equals to -2 over 7, which is below the x-axis. And the next one is 3. The point we're going to get is 3 over 2 and -2 over 7. So the last one is that one. That one we choose 3. If you put 3 in there, R of 3 is equals to 0.4. 0.4 is positive, so it's going to be above. If it's negative, below, positive, above. So what we're going to get, the corresponding values is 3 and 0.4. Now we get the points. We get this point here, we get this point, we get this point. We know where our asymptotes are. So we will be able to use that to draw the graph. So all the steps we did, like I got the earlier paper here, where we get step 1 to step 4. Now we get here step 6, step 5, step 6. So that's what we're going to combine to draw the graph. So we know where the vertical asymptote is. We know where so I'm going to use a fresh paper to do the graph. So I'm going to go ahead and draw the axis. This is the x, that is the y. So from all the information we get on the previous step, like that step 1 to step 6, that's what we're going to use to draw this graph here. So the first thing we found was the domain of the graph. So the graph can never be at, let me write that 1, 2, I get -1, -2, I get 1, 2 up here, -1, -2 up. That's positive y, negative y, positive x, negative x. Okay, we get our asymptotes at 2 and -2. That is our, sorry, that's our domain. That was the first step we did. That was our domain. -2 and +2 was our sorry, our domain was x is equal to all numbers except these two. So it means the graph will never be on this line here. Like the graph will never be on -2 or 2. It will never be on there. Okay, now what we're gonna do is draw our asymptotes. I'm gonna go ahead and draw the asymptotes. The asymptotes are x minus 2 and x minus 1, which is this line here. That is our vertical asymptotes. Okay, that is our vertical asymptote. So the points we get from the table, I'm gonna go ahead and plot those points. So those points are -3 and -0.8. -3 is going to be here. So 0.8 is going to be around here. So that point is going to be right here. We get that point here. So the other point I'm going to draw is we get -1 and 2/3, that one. -1 and 2/3. So -1 and 2/3 is going to be, as -1 on the x is going to be here. 2/3 is going to be around here. 2/3, that's less than 1, so it's going to be around here. So I'll put that around here. 2/3, yeah, that will be around. It's just this region around here. Like the graph, the scale is not accurate. I just try and assume, just put the number like the place I thought this thing is supposed to be. It's not in scale. Okay, I plot that one. The next one is 3/2 and -2/7. 3/2 and -2/7. So 3/2 on x, that's going to be around here. 3/2, that's like 1.5. It's going to be around here. And -2/7, that's going to be around this end. So I'll get another point here. So I'll get another point there. And the next one is 3 and, it's going to be 3 and 0.4. 3 and 0.4. So 3 is on x, 2, I'll get 3 here, and 0.4, that will be around this end. So here, from the information we get, we can draw now the graph. You know, this is the axis, this is the asymptote. It means the graph will never pass there. And this is the horizontal asymptote. The horizontal asymptote, the graph passes at x is equals to 1. So we know that is a point here. And we already find from the other step, we find the y-intercept and the x-intercept. We already find this one is the x-intercept. So the y-intercept is the two intercept. This is one of them. The other intercept is going to be right here, 0 and 1/4. That's going to be around here. So you see, like the points we get this is the vertical asymptote. The graph will never go past that. So it means we can draw a graph from that. It means the graph is going to be getting closer to this line, which is the asymptote, but it will never pass it. So this is going to be the direction. It will get closer to this line, but it will never touch it. This asymptote goes for like infinity. It will get closer to that. So this is going to be the graph. So we get this point here and this point, and it's going to get closer to the other line too. Going to get closer to it, but it will never touch it. So it's going to go up there. So we get that one. So we get another point here. We find that this thing too is the horizontal asymptote. So it means the graph will get closer to this line and these two lines, but it will never touch them. So it means it is like this then. It's going to get closer to that, it will never touch it, and closer to that, that is the horizontal, and never touch it. So that's going to go like that. So the same thing here, getting closer to that and that. So that is going to be like this, way up there, and like this, way up there. So from the information we get from step 1 to step 6, that's what we use to draw this graph here. This is the domain. We know that it will never be on this line, and that is the same as the vertical asymptote. That is the horizontal asymptote. That's what helps us to draw this line and that one, the vertical asymptote. We find the x-intercept, the y-intercept. When x is equal to 0, that is the y-intercept, the x-intercept. So we find all that. So this is the graph that we come up with. That is the final graph. Okay, if you get any problem on college algebra, you can, or if you see like anything on the video that you don't really understand, you can come on the third floor. Like I'm always there. My tutor hours are between On Monday between 12 p.m. to 7 p.m. and on this thing. On Tuesday from morning like 8 a.m. to from 8 a.m. to 11 a.m. and from 12 p.m. to 12:30 p.m. to 4:30 p.m. That's like on Mondays and on Tuesdays and Thursdays. I get a similar schedule to this one. I get a similar Tuesday schedule to this one, to Thursday. So my Thursday and Tuesday schedule are all the same. I'm there from 12:30 in the morning to from 8 o'clock in the morning to 11 a.m. and from 12:30 to 4 p.m. on Tuesdays and Thursdays, and Monday from 12 p.m. to 7 p.m. So if you get any college algebra problem or maybe like other math classes, you can come down there.